Now we are going to discuss the problems of manometers. Already we discussed the working of manometers in the previous video. Now in this video we are going to discuss about the manometers. What is the how to do the problems on manometers? I solved the problems, important problems that are given in previous papers also. Now in these problems, a simple YouTube manometer, about YouTube manometer given. A simple YouTube manometer containing mercury is connected to a pipe in which a fluid specific gravity 0.8. Fluid specific gravity is given as 0.8 and have vacuum pressure is flowing. Vacuum pressure is flowing. The other end of the manometer is open to atmosphere. The other end of the manometer is open to atmosphere. Find the vacuum pressure in the pipe. Find the vacuum pressure in the pipe if difference of mercury level in two limbs is 40 centimeter. Now difference between the mercury distance is given as 40 centimeter and height of the liquid left to center of the limb is given as 50 centimeter. Already discussed the problem that about the YouTube manometers, derivations of YouTube manometers. Now we can use, by using of the derivations we are solving this problem. How can you solve this problem? First we have to write the given data. The first specific gravity of liquid is given as 0.8. Specific gravity of mercury is 13.6. It is constant. Whenever it is not given, we have to remember it. It is 13.6. Next, density of liquid. Now density of liquid, how can you get the density of liquid? Means we have to multiply with 0.8 has been multiplied with density of water. Density of water is equals to 1000. We know that specific gravity is equals to density of liquid by density of water. From that, density of liquid is equals to specific gravity multiplied with density of water. We get 800 kg per meter cube. Next, rho 2. Rho 2 is nothing but density of mercury. Density of mercury is equals to the specific gravity is 13.6 multiplied with density of water. We get 13,600 kg per meter cube. Next, H2 is the mercury level difference. Mercury level difference is the H2. H2 is taken as 40 centimeter. Next, H1 is the height of left limb. H1 is the height of left limb which is given as 15 centimeter. H1 is the height of left limb which is given as 15 centimeter. That is nothing but height of liquid. Height of liquid is given as 15 centimeter. That is 0.415. This problem has been drawn with the help of a diagram also. I represented with the help of a diagram also in order to understand very easily. Now consider YouTube manometer. YouTube manometer, one end is atmospheric and open to atmospheric, other end should be vacuum pressure, creating a vacuum pressure here. Now from center of the pipe to the vacuum distance is given as 15 centimeter. That is H1 is given as 15 centimeter. H1 is given as 15 centimeter. 15 centimeter means 0.14 meter. And H2 is given as, and this height is given as 0.4 meter. This height is given as 0.4 meter. Now we have to find out the pressure created in this pipe. The pressure created in this pipe. We have to find out. The pressure should be, we have to find out. How can you find out? By using a formula. Formula is equals to, we have to find out the pressure rise at the right limb is equals to pressure rise at the left limb. Pressure rise at the left limb is equals to pressure rise at the right limb. Now using the relation equaling the pressures above A, we get P plus using the diagram. P plus, here the pressure is P plus rho 1 G1 H1. The density is rho 1. The gravity is G1 H1. There will be derivation in manometers also. Plus the manometer is also, the mercury is also in the left limb itself, become as P plus rho 1 G H1 plus P2 rho G H2. That is equal to 0 at the right limb. There may be no, above the 0 line there is no pressures. Now the pressure remains 0. When our pressure remains 0, now it remains, when our pressure remains 0, we get P plus rho 1 G H1 plus is equals to 0, we get P is equals to this value. P is equals to this formula. Now P is equals to substitute the values. Rho 2 is known. G is 9.81. H2 is 0.4. And this is rho 2. Rho 1 is nothing but 800. 800 means 0.8 into 100. 9.81 gravitation constant. H1 is given as 0.15. By substituting wells, we get the value P is equals to minus of this value. By calculating this value, minus of this value is minus 5453.2 Newton per meter square. Minus 5, where minus indicates, negative indicates, the value of negative indicates the pressure is vacuum pressure. Whenever the pressure is vacuum, below the atmospheric pressure, that's why it's minus. Now, vacuum pressure inside the pipe P. Now, at the pipe P, the vacuum pressure P is equals to 54543 Newton per meter square. Now, unit of pressure is Newton per meter square. This is the answer. Very simple. Just by taking the reference line, we have to consider the pressure forces. Next, second problem. Differential manometer is connected to A and B. Differential manometers means used to measure the difference between the two pressure heads A and B of two pipes as shown in the figure. Figure also given by university paper. I also defined it. I will also show the diagram. The pipe A contains liquid of specific gravity 1.5. Pipe A contains liquid of specific gravity 1.5. Pipe A liquid specific gravity of 1.5. Specific gravity has been given. Pipe B contains liquid of specific gravity 0.9. Two are different fluids, 1.5 and 0.9. And here the pressure set A and B. Pipe A pressure is 1 kilo force per centimeter square. Pipe B pressure is 1.8 kg force per centimeter square. Respectively, find the difference in mercury level in differential manometer. We have to find out mercury level, that is H we have to find out. First given data, specific gravity of liquid. The liquid specific gravity, first liquid that is A liquid is 1.5. Specific gravity no int. S2 specific gravity of mercury 0.9. Specific gravity of second fluid is 0.9. Next, density. Now by using this specific gravity you can find out the densities. We know that rho 2 is equals to density of liquid is equals to density of this liquid is equals to 0.9 multiplied with 1000, it is 900 kg per meter cube. Next, density of liquid, this liquid is equals to A liquid is equals to 1.5 into 1000, that is 1500 kg per meter cube. Now pressure at A, given data, this is the given data. Pressure at A is equals to 1 kg force per centimeter square. 1 centimeter square is equals to, we get as 1 into 10 power 4 kg per meter square. 1 into 10 power 4 kg per meter square. I am converting centimeter square into meter square into 10 power minus 2 whole square. By taking on numerator, we get 10 power 4 meter square. Next, now kilojoules, kgs has been converted in terms of newtons. Kgs convert into newtons by multiplying with gravity. Gravitation constant 9.81. Now kgs has been converted in terms of newtons. PB, pressure at B is equals to 1.8 kg force per centimeter square. That is 1.8 into 10 power 4. Why? Because I am converting centimeter square into centimeter square into meter squares. That's why 10 power 4. Now kgs has been converted into newtons by multiplying with 9.81. 1.8 10 power 4 into 9.81 Newton per meter square. Now this is a diagram has been given. That has been given in paper. PA 1 kg force per centimeter square. Specific gravity 1.5. Specific gravity 0.9. Pressure B. Pressure B is 1.8 kg per centimeter square. Now level of this liquid is given as 3 meter. Level of this is given as 2 meter. And height of mercury is equals to h. Level of this one is 2 meter. Level of this liquid is level of B liquid is 2 meter from the center, and h is the mercury level, and 3 meter height. Now we have to calculate. First we have to consider the datum line here. This is the datum line. Now we have to clear the left limb. This is the left limb and this is the right limb. This is the left one, this is the right one. Now consider the left bulb. Left bulb, whenever consider the left bulb, PA is acting. PA, pressure force is acting, PA. Why? Because it is given, pressure force is given, as well as rho 1, the density is rho 1, G constant, H1, that is height is equals to 3 meter. That height is equals to 3 meter plus 2 meter. From the datum line, it is also 2 meter. 3 meter plus 2 meter. Now its specific gravity is 1.5, means density become 1500. 1500 into 9.81 plus 2 plus 3. Above the datum line, it is 2 plus 3. From this level to this level is, from liquid one is 2 plus 3, 5. 2 plus 3 plus PA, as well as mercury. Mercury specific gravity is 13.6 into 1000. We get in terms of densities. Multiplied with 9.81 G. Rho G H. Rho G H is nothing but pressure. All should be pressures which are acting in the which limb? Which limb means left limb. Now we get by calculating 13.6 into 1000 into H is 9.1 plus. Now pressure we get is also given is we get 9.81 into 10 power 4 Newton per meter square. Convert them into Newton per meter square. Now pressure of left limb, right limb. Now we are considering the right limb now. Now equating these two, by both are balancing by, because we are equating these two limbs. Now pressure at right limb is equals to, is specific gravity is 900, 0.9 means 0.9 into 1900, G 9.81 plus H, we consider from above XX, H plus 2 from the center, H plus 2 plus PB. The pressure acting at this point is equals to 1.8 kg force per centimeter square. The pressure acting at this particular bulb is equals to 1.8 kg force per centimeter. Now equating the two equations 1 and 2, by equating 1 and 2 equations, we get two equations are equating. First equation is maybe second equation. Now dividing with respect to 1000 into 9.81 rho G, dividing by rho G on both sides. Now it is rho G, it is also rho G, 1000 is there, this is also rho G. Now dividing by rho G on both sides, we get remains by cancelling out, after cancelling out 13.6 into H by cancellation, by multiplication we get 17.5 plus 10, here we remains only 10, plus H plus 2 by cancellation we get H plus 2 into 0.9, H plus 2 into 0.9 plus 18, by cancellation we get 18 value here. Okay. Next, after calculation we get this is the H value, this one I am taking constant on that side. By taking constant on that side, that remains 0.9 into H, 0.9 into 2, 1.8 plus 18. Now taking these terms on one side and the other terms on one side, H terms on one side and other terms on one side, we get 13.6, 0.9 H, 19.8 minus 17.5 is equals to this value. Okay. After getting these values, now find out H is equals to 2.3 divided by 12.7. We get this value. This is the answer. Now the difference of mercury level is equals to H is equals to 0.181 meters. This is about the manometers, working of manometers, different manometers, and the problems, how to solve the problems for manometers. Thank you. How to solve the problems